Hi everyone, my name is Lydia and this is what I wish they taught me about econometrics and introduction. We've derived the interpretation mathematically on the level log model, so now let's apply it to a concrete regression and interpret the coefficients correctly. Suppose that the model that we are talking about is consumption equals to 500 plus 40 ln of income, where consumption is measured in pounds and income also measured in pounds. In this case, the slope the beta one had is clearly the 40, which using the rules that we know by now is a 1% increase in X is associated with a beta 1 over 100 change in Y. Okay, so this is the standard interpretation. So in our case, based on the 40 that we have, it's going to be 40 divided by 100, so 0.4. So putting context and using the actual variables that are given to us, we're going to say that a 1% increase in income increases or is associated with an increase of consumption of approximately 0.4 pounds on average. Okay? So keep in mind, the change in X is the one that's in percentage. The change in Y, so in this case consumption, is the one that is in units, meaning the pounds. That's the structure. Now, suppose that income increases we've got a by 10%. Okay. In this case, you're going to have your change in the Y is going to be approximately the 40, the beta one that you had, times 0.1, okay, which is the 10% here, and that is 4. So in this case, and keep in mind, this is something very normal, especially in articles or in books, because sometimes the numbers are just so small that they don't really give you an economic meaning or understanding of the situation. So it might be a little bit easier to say, well, actually, if my income increases by 10%, then I see my consumption now increasing by 4%. Okay, so very mechanical, very clean. It's the same concept. It's just that also most of the times for clarity, economic clarity, you might want to know how to adjust that instead of a 1% increase to 10% increase or 20% increase, depending on the situation. Now, if we use the derivative, we're going to have the dy over the dx being equal to 40 over x, okay? So keep in mind, if income is, let's say, 1,000, so I'm not saying the ln income, I'm saying if income by itself is 1,000, then I'm going to have 40 divided by 1,000, which is the 0.04, okay? Which means that 1 extra pound, okay, increases consumption by literally 4 pennies. Okay. And the same, if income is 2,000, you're going to have 40 divided by 2,000, and it's going to be 2 pennies. So keep in mind in here, the marginal effect of a 1 unit change in income depends on the level of income. But the effect on 1% change in income is instead constant. So here, let me just write the 2,000 as well. So in this case, you're gonna have this, by 2,000, which is just 0.02. So look, here we're looking at the marginal effect of a 1 unit change in income depends on the level of income, but the effect of a 1% change in income is constant. Okay, so that's the key contrast in here. Common mistakes you should be aware of. A lot of the students most of the time say a 1 unit increase in income increases consumption by 40, which is clearly wrong because we're no longer in the level model. You can say that the 40 applies to the log income, not the income itself. Okay? So, as a summary overall, in the level log model, keep in mind a 1% increase in X is associated with beta 1 over 100 unit change in Y. Conversely, if you have 10% increase in X, that's going to be 0.1 times the beta 1. So 10 beta 1 divided by 100 unit change in Y. So coefficients translate percentage changes in X into unit changes in Y. I hope this was helpful, and I'll see you in the next video.